Hello guys, I hope you all are doing well, and we are going to continue pointers in this tutorial. And in today's video we will be talking about single pointer, right? So let's go through it. In the previous video we had seen that in a normal variable, if I say a will hold a value, like there is like int a supposing, and end of a will be address, right? Now in single pointer, let's say it is defined as int asterisk p, then note that asterisk p will always have a value, p will always have main address of a variable of same type, same data type, we can say data type. This is the main address, right? Remember, main address, we had called it main address of a variable, or I should say normal variable p. Okay, and end of p is the main address of pointer variable. Okay, you have to remember this, always remember this, and for any other things it will give us error. Okay, so let's take some example. For example, I am defining a variable int a, and I am writing a equals to 6. I am also defining, let's say, a pointer, single pointer is defined as like only a asterisk with variable name. Now what happens here, there's a address of a, let's say it is x, this is a. If I do the printf of a right now, it will give me 6. Okay, but yeah, 6, leave it. When I am defining it like that, p, for p it will be end of p, this will be the main address, p it will hold main address of normal variable, and okay, now what is this? This is an address, and this address is asterisk p. What is stored in this address will be asterisk p, and this will be value. Okay, I can write like this will be a address and this will be a value, okay, of same data type. For example, an integer pointer variable will only hold the address of integer normal variable. Okay, let's look at this. Now if I am doing p equals to a, okay, let's see whether it is correct or not. P, what can p hold? Main address of a normal variable of same data type. Okay, both are same data type. Okay, one condition is true. Then p equals to a. What is a? Is a an address? Main address of normal variable? No, main address is end of x. So this will give me error. Okay, now if I am writing p equals to, let's say there is another pointer variable q, single, end of q. Okay, what is this? Main address of pointer variable. Is it possible? No, it is not possible. It will give me error. Main address of a normal variable is only possible. No other address can be defined there, right? Just leave it. Now let's go through simple by easy. I am writing p equals to end of a. Is it okay? P, what can p hold? Asterisk p. P, main address of a normal variable. Normal variable main address is end of a. Okay, so this is valid. Now what happens is, there in memory, this is holding the main address end of a, which is, we had defined it here x, and let's say it is y. Okay, now this is an okay, this is okay. Now if I am doing printf of a, let's say printf of end of a, printf of asterisk of p, printf of p, printf of end of p. Let's go through one by one. Okay, after that pa is simple 6. End of a we had given it x. This will be any number or hexadecimal, it depends on you how you are going to represent it, right? So let's say this is x. Okay, asterisk p. Now in the previous video we had said that only an address can be dereferenced. Remember? You should remember. Okay, so what is p here? P is now the address of main address of A. So it is what? It is what? An address. So it can be dereferenced. Now what is present in P? P present is end of A. Okay, this is P, right? Right now P equals to end of A. P equals to end of A or X, whatever you call it. And if I write asterisk, now what does that mean? Value present in this address. Now what is value present in this address? What is value present in this address? This address is holding A. What is printf of A? Printf of A is 6. So this will give me output as 6. Okay, just let's go once again. I write P equals to end of A, right? Now this is holding an address. Remember that in the previous video I said you that this can also hold a value or address. Okay, in normal variable case it can only hold value, but now since we are talking about pointers, it is holding an address. Now it is holding an address. Okay, address of what? A normal variable. Okay, address of what? A normal variable. And when I am doing asterisk p, then it is happening like something like this. Now what will be the output of this? Obviously this will be end of A, something present here, and it will be printf of A 6. So asterisk of P will be 6. Asterisk of P will be 6. Now P, what is P? P is address of A. Address of A. Address of A is equals to what? X. X is equals to X. End of P. End of P. This will be Y. Any other quantity. Okay. These will not be the same. Will not same. Okay. So this is the basic example. Let's go through some other examples also. Okay. Okay. So let's say when we are encountering errors. Okay. Let's go easily. We are saying int a equals to 4, b equals to 6. Just be patient a little. It's going to be a little complicated, but not too much. Asterisk p, right? Now I am writing. Okay, let's make memory location also. End of a, end of b, end of p, and this something like asterisk p also there. Okay, now remember this. Okay, now if I am saying a is equals to b, it is valid. A can hold a value, b is a value. If I do print of b, it is a value, right? A is equals to end of b, wrong. A normal variable cannot hold the address. We had studied it in the previous lecture. Okay, now vice versa also for b. B equals to a is valid, b equals to and a is not valid. Okay, this is for normal variable. Now let's say about pointers. If I am writing p equals to end of a, it is valid. Yes, it is valid. Why? Because this is the main address of a normal variable. Okay, if I am writing p equals to end of b, it is fine because it is the main address of a normal variable plus both are of the same data type. Okay, now if I am writing p equals to 6, it is an error because this should be address of same data type and it cannot be a value. In the previous video I had said that a constant 6, 18, character, these are always be treated as a value. So we can't give it a value. Remember, it can only hold main address of a normal variable. Main address of the normal variable. Main address. Remember that. So right now I am trying to give it a value where it cannot hold, p cannot hold a value. Okay, let's say p is equals to a. Again, this is a what value, we cannot hold it, error. P equals to b, error. Okay, now p equals to and a, p equals to and b is valid, and this, is there any condition? Yes. If I am trying to do and of p equals to and of a, what will happen? Error, because in the previous video we had said that the main address can never be altered. Okay, it can never change. So whatever it is single pointer, double pointer, normal variable, whatever it is, the main address will never change. Okay, so this will give me error. Or even if I do and of p equals to 46, error, because this is a value and this can also never change. Okay, now let's talk about asterisk of p. Okay, if I am saying asterisk of p equals to a, is it okay? Yes, it is okay. Why? Because it should hold a value. Now asterisk p is holding a value. A is what? Print of a is what? It is a value. It is a value, so it is okay. Now if I am writing asterisk of p equals to b, it is right, because b is right now a value. Okay, if I am writing asterisk p equals to and of a, now and of a is not a value, this is an address, but asterisk p can only hold a value, right? So this will give me error. Okay, so this is like the flows go. You have to remember all the rules of the pointers and single pointers to do any questions. Okay, now let's take some other example for the practice purposes. Okay, so let's take some examples now. Okay, let's suppose there is a variable, normal variable, I am assigning it to 6, and there is also a pointer variable asterisk p. Okay, what I am doing is that I am assigning this p equals to end of a normal example. Okay, now I am writing, let's say there is another variable p equals to 7. Now I am printing of a, printf of end of a, printf of b, printf of end of b, printf of p, printf of end of p, and printf of asterisk p, right? Okay, so what happens? A gets a memory location, b gets a memory location, pointer gets the memory location. Okay, and this is end of a, end of b, and end of p, and let's say it is x. We are assuming it could be anything, right? And this is z. Okay, this is a, this is b, and this is p, and it will also having something like asterisk p. We can also have this. Okay, so now printf of a, what will be printf of a? A, printf of a equals to 6, simple. End of a x, simple. Printf of b, simple. Printf of b 7. Okay, printf of end of b, it will be simple, y. Printf of p, now printf of p, what we are doing here? Now the p, now this will be holding the address of, here it is equals to end of x. Okay, so what? So look, print of p. Okay, now p is what? End of x, and end of x what? X, sorry, end of a, sorry, I am really sorry, this will be end of a. We are writing here end of a. Okay, end of a is what? X, end of a equals to what? So print of x, or we can simply say it will give us x. Okay, or you can here also directly say it will be x. So this will give us x. Okay, end of p, p of end of p, print of end of p, set, simple. Asterisk p. Now what is p? P is equals to end of a. Okay, now I am writing asterisk p. What is asterisk p? Asterisk of end of a, right? What is asterisk of end of a? What is asterisk of end of a? A, what is a? A is 6. A is 6. So p will become, asterisk p will become 6, and it will give us 6. Okay, let's append this a little. right? Now I am writing asterisk p is equals to 18. Okay, and now I am asking what is the printf of asterisk p and printf of a. Now note what I am doing here in this statement, asterisk of p equals to 18, right? So what was p? P was end of x, end of a, sorry, p was end of a. So now if I am changing what is asterisk p? Value present in this address. Now I am changing the value present in this address. Okay, now I am changing value present, dereferencing the address, value present in this address. So what is the address present in p? This address, right? This address, and now I am changing it to 18. So whatever was present here before, which was 6, now I am changing it to 18. So now asterisk p will give me 18 and simple a will also give me 18. Okay, so now let's understand this example again. Okay, we'll go really slow. What I had done was p is equals to end of a, right? Just only look here now. Okay, 1 minute. P is equals to end of a. That means now p was pointing to a memory location. P was pointing to a memory location, and end of a was previously also referencing or was pointing to a memory location here. Okay. Now if I am writing p, it is also give me x, and if I am writing end of a, it will also give me x. Okay. If I change like asterisk of end of a equals to 88, right? So whatever was present there, I am changing its value to 88, or I can also change it with pointer, because both are pointing to the same memory location. Okay, we have to see that, we don't have to see what is the name of that variable. Okay, we only need to focus on the memory location. We know that both are pointing to the same memory location. So if I am also writing asterisk p equals to 99, then this value is changing. Okay, so if I am writing now what will be the a, it will give me 99. What will be I will be p is equals to, and it will give me also 99. Asterisk p equals to also 99. Okay, like this p now is address of here, asterisk p is telling the value here, and that's all. This can never change, this can never change. Now let's have another example. Let's look at the second example. Another example. There is this int a equals to 2, b equals to 6. Okay, I am writing p equals to end of a. I am saying asterisk p is equals to 88. Then I am writing p is equals to end of b, and I am writing asterisk p is equals to 99. And then I am asking for printf of what I need. Let's say everything a, b, end of a, end of b, p, asterisk p, and end of p, right? Okay, so let's see. There was, this is not working. There was something a, end of a, let's suppose it is x. It could be anywhere a value. It can also be given that this is the memory location. This is end of b, let's say y, and this is end of p, let's say z. This is a, this is b, this is p, and it is also having asterisk p, something like that. Okay, now the first statement, p is equals to end of a. Now what p is holding? End of a. Any changes with this address will also reflect this address. Okay, asterisk p equals to 88. Now I am saying that asterisk p is equals to 88. What does that mean? Asterisk p is what? End of a equals to 88, or we can cancel out it. That means that a will become 88 in simple, like we had seen in previous example. Now a has become it was previously 2, now it has become 88, right? Now A is 88. Now I am changing, I am saying that P is equals to end of B. Now I am saying P is equals to now end of B, and now I am changing asterisk P equals to 99. What does that mean? P was holding end of B now in this line, okay, in this line, from this line. Now I am saying asterisk P is equals to 99. Asterisk P means what? Asterisk of end of B, okay. Now I am saying this is equals to 99. What does that mean? B will become 99, or you can cancel out, but I suppose this is better to understand. B become 99 or asterisk P becomes 99. So now this was previously, this was previously 6 and now it will become 99, okay. So now nothing is changed, okay, nothing is changed. Now let's see what is A now. What is A now? It is 88, so it is 88 now. What is B? It is 99, 99. What is end of A? End of A is X. What is end of B? End of B is Y. What is P? Now what is P holding right now? We had not changed it after that, right? We did not change it. So P is holding right now end of B, which is Y. So it will give me again Y. What is asterisk of P? P asterisk of P, asterisk of P, asterisk of P. Asterisk of P equals to asterisk of end of B. What is asterisk of this mean address? Value present in this address 99. So asterisk of P is 99. So it will give me 99 and this will give me Z. Okay, remember that, and always remember that these rules must always be followed. For example, if I am writing here P equals to A, okay, it will give me error. Okay, we had seen these examples before, but always remember these rules, okay, for the error process, for identification of the error. For example, if I am writing P equals to asterisk P, this will also give me error, because P can only hold main address of a normal variable, okay. So I hope that you understand single pointers, and if you have any doubt, you can ask me in the comment box and share it up. And thanks for watching. I hope to see you in the next video.